All right, we're in business. Okay, so this one's up and running. Sorry about that. I don't know what happened. This program just went berserk. Okay, so we're back. Glad you could join me again. Had about 1,000 of you there on there for a quick second while you watched me panic. That's what happens though. Gotta be quick with this new tech. All right, so let's get down to business. Now you guys want to get on with your Saturday night. So I'm here to talk about the severe weather potential for Sunday. We've talked about this off and on this week since last Sunday, and then I did one on Wednesday and I did one on Friday morning or Friday lunchtime. Kind of give an idea what you can expect. So not much has changed. It's kind of a late last minute run of moisture here in Oklahoma as the storm system comes in from the west. If it was any other time of the year, say April and May, the moisture wouldn't be a problem, wouldn't even be a question. And yes, we'd be talking about some pretty significant severe weather as a result of that. Probably even a pretty good outbreak. But with the way it is now, it's a very questionable call. And I understand the idea here is when it's this questionable, you have to play it safe. So I get that, because if you were to go real brave and go, not a big deal, nothing's going to happen at all, and then if severe storms go up, produce some hail, wind, isolated tornado, something like that, well, then your name's mud. So I understand you don't want to go that route. So you kind of ride the fence and dance around a little bit. So what we're going to do is show you what is the same and what has changed since we've been talking about it earlier this week. And in general, nothing has significantly changed. There's been a couple of trends, but just because a model says something doesn't mean it's actually going to happen. So that's the kind of a key there. Okay, so we got plenty of you watching, so let's get into business. I think everybody's caught up now, and you can disregard that last Facebook Live. I've already hit the delete button on it. Okay, so you know what I like, and that's to get down into the map area. So without further ado, here we go. Okay, so the first thing that I want to talk to you about is we do have the risk from the Storm Prediction Center. They have put us in an enhanced risk. Now, enhanced risk just means it's more likely than a slight risk of severe weather. And that is right here over central Oklahoma. Stretches on up toward Tulsa, down toward the north end of Dallas. So this little sweet bullseye area right here in central Oklahoma. And that's because that is where all the moisture is expected to pool, along with the best shear in the atmosphere, closer to the upper level storm system, closer to the dry line, yada, yada, yada. All right, now the wording on this is the same thing that I've been telling you for a long time. So and which is good. It's always good to see other experts agree with me on my thought process. Now, again, that's the deal, is that this could always change the last minute. But they were saying that water vapor imagery contains considerable subsidence way down into Texas and Mexico. The soundings down there this morning had a very shallow layer of rich moisture. Remember what I said, ankle deep? That's what shallow layer of rich moisture means. So that's the questionable deal. And with that, you typically get some pretty good supercells that go up with hail. So probably some pretty good hail makers and some damaging winds in there. And then the big question is, a lack of greater moisture may hamper near-surface supercell processes favorable for tornadoes or tornadogenesis. In other words, if we do not have the deep moisture in here, as the models are suggesting, there really isn't a tornado threat. It's just a high-based, hail-producing thunderstorm with some wind in it. That's what I've been going for all week, because that's the signals the models keep saying. But I understand you got to kind of ride that fence just in case the moisture is a little bit better than what actually comes in here. So here's the deal on the moisture. This is a sounding from Corpus Christi. And way down here in the bottom, all you need to care about, that I'm going to tell you, is that it's still fairly dry. Now, the model forecast for this area this evening, at this time frame, had it actually pretty moist down here in the lower levels. So the model's already off. It's already wrong. In other words, the models think there's more moisture in that spot than there currently is. Shocker, I know. Well, that's the kind of thing you have to check, because down here into the Texas coastline is where the low 60s and to near 70 dew points reside. Way down here. All this moisture has to transfer all the way northward to get into Oklahoma by tomorrow afternoon and evening. It is going to be a race with the clock, and it's going to get here at the very last second. The question is how much of this deeper moisture mixes out to shallow moisture, and if it even makes it here. There's a lot of uncertainty in this, and that's why the model data hasn't been exactly clear, because it's a little aggressive with this moisture transport. Like I said, if it was April or May, not a problem. I'd believe it in a heartbeat. We're still in March, and that's where I'm a little nervous at buying into this solution. So that's the latest with the moisture situation and then what can potentially happen. So let's put this into layman's terms for you. Well, if, and I'm again a big if here, the models indicate that low 60 dew points can get here, which I still doubt, but if they can, they're going to pool right here over central Oklahoma. Now, this is the first wave, and a lot of times you get a good first round of moisture that's pretty deep that will pull in, like you see in these yellow areas. But behind that is a drier wave down here in southern Oklahoma that moves in. So you get kind of an initial shot, but then it's followed by drier air. This happens all the time. Well, you get a little shot of drier air in at the wrong time of the day with max heating and max convergence in the dry line, you get nothing. And so again, this is going to be one of those just very close call situations. Okay, so that is where the dew point values are. The CAPE values, I've shown you this, is a measure of instability along with those dew point values and the heat from the temperatures. It's got that stuff anchored right here over central Oklahoma. Again, focused pretty much right along the dry line. So if I were to show you the dew point values again, the dry line, let's see, there'll be a low out here, and the dry line will kind of do this little number right here. And then you'd watch for storms to develop here, 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 in this area. And then they would move to the east-northeast. So that's kind of how that would unfold. Now, does this particular model show storms? Well, let's take a look. This is 4 o'clock on Sunday. It's starting to bubble up some towering cumulus into some showers here over central Oklahoma, right just on the west of I-35. As we go into Sunday afternoon at 5 o'clock, it's starting to develop a couple of thunderstorms, but they peter out. One hangs in there, real weak one, here in Creek County, heads up towards South Tulsa, and then you get a batch down here into southern Oklahoma, where I think the main show would be, because then this will work its way east-northeast into the moisture that continues to pool in there after dark. So then these storms down there get a little more ferocious with more wind and hail. Again, by this time, we're at 9, 10 o'clock in the evening, and the tornado threat's pretty much over, but you're going to get at least some rough thunderstorms in southeast Oklahoma. So this is a high-res model, which, again, doesn't show much of anything happening with this particular system. Now, I'll show you another model. This is the really short-term high-res, which is experimentally run beyond the time frame the model is designed for. So there's going to be a lot of error that gets reintroduced each hour you go in time. Well, this is 4 o'clock, 5 o'clock, 6 o'clock. Now, this would be a scary incident because it's got supercell, 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 supercell mania. And you don't want supercells, especially that many of them. So that's basically a supercell outbreak over Oklahoma. A lot of wind, a lot of hail. And probably in this particular case, the model probably went so crazy, it's got probably a couple of tornadoes with some of these. And these all pretty much group and then move off to the east by 7 o'clock here in northern and eastern Oklahoma. And then kind of continue on through the evening hours. And then by, I think, 10 or midnight, starting to move out of the state. That is an extremely aggressive scenario. Here's another shorter-term high-res model. This is for 4 o'clock on Sunday. It's got one lone supercell out there in western Oklahoma. Then it produces one right here in, let's say, northern Oklahoma County, southern Lincoln, so maybe around the Edmond area. And that kind of congeals into a cluster of multi-cell storms. Multi-cell storms are not nearly as potent as supercell storms. You want multi-cell storms. They're heavy rain makers, pockets of hail and wind here and there, but not necessarily nearly as significant or strong. And that cluster moves through Tulsa and off to the northeast. Okay, so not nearly as ominous as the other model we looked at. Here's another version of this same model tweaked in a different manner, different parameters, different schemes, different physics, and you get more of a supercell type output here in southern Oklahoma. There's one here south of the metro. As we go through time, those kind of congeal a little bit to kind of a combination of a couple of supercells, otherwise some multi-cell stuff. So it's still not nearly as ominous as that one. So basically we have two that just say scattered showers and storms, maybe a couple of supercells thrown in. You've got one that says nothing's going to happen until late in the day, after dark, in southern and southeast Oklahoma. And then you got one going crazy. All right, well, I'm going to discount the one going crazy for now. And we'll just see. Tomorrow morning, we'll see how well the models do with the transport of moisture. And so that data should be, knock on wood, much better as far as the estimate of the dew point values. All right, so this is the WRF model from the Texas Tech. It's usually pretty good. Let me zoom in a little bit more for you. It's got looks like a supercell popping up here in the northern part of Oklahoma County by 5 o'clock. Let's see here. And then by 6, those kind of move up north toward Pawnee. You get a couple down there around Ardmore. And you kind of get that cluster down in Ardmore in southern Oklahoma. It kind of jives with that first model I showed you. So that's 2 for more of a cluster of storms in southern and southeastern Oklahoma. Not much happened in central, just 1 or 2 storms, and they move off, and that's it. Those 2 models combined is more of what my forecast is leaning toward at this point in time. So yes, I think there'll be a couple of supercells. Yes, some hail and wind with them. They'll probably marginally severe at first, and probably eventually get their act going a little bit as we go after the probably 5 o'clock hour, as they move off away from the Oklahoma City metro. The tornado threat extremely low with this scenario, again assuming that we're moisture starved, and that's what I'm going for right now. Now we'll show you, let's see here, I'll show you this earlier this week. This is the LCLs. So the height of the cloud base, and we read that off the Storm Prediction Center's discussion a little while ago. You need cloud bases that are fairly low for tornadogenesis. And if we look at 4 o'clock, there is a pocket of very low cloud bases right here over central Oklahoma. I mean, we're talking kind of all congealed right here. As we go into the next hour, it's still there. As we go into the hour after that, we start to get to the 7 p.m. to 9 p.m. time frame, and that's typically when low-level jet comes in. You get a little bit more moisture kicked that way. So that's why there's a small window, I think, for any of the kind of supercell type structure storms, if they're still out there, between 7 and 9 p.m. That's the better time frame to produce an isolated tornado. And as we looked at the radar imaging, that probably is going to happen more across southern and southeastern Oklahoma. They're just for that very short period of time. That's the way it looks right now. Let me see if there's anything else I want to show you. One more thing, and that will be the wind. Okay, so I showed you where the dry line was out here in western Oklahoma, and we've got all the warm, supposedly low 60s here in central Oklahoma. So you have to take a look at the convergence along the dry line and see how that's going. And boy, this is going to be hard to see. Let me see here. Zoom that in for you. Does that help out a little bit? Okay, there we go. All right, so these are all streamlines that come in like so. And here they come in here, and they come in here. And you kind of have 2 areas of low pressure. You got one out here, and then you got one up here. Well, that's kind of messing up the flow. Because the wind will kind of flow toward the area of low pressure, and then you got winds that flow in here. So, this kind of causes that dry line to kind of come in like this. But it's messy. Because this area of low pressure out here to the west, it's not a clean surface map. Plus, the wind speeds in here, this is the kicker. And let's see, the scales up to my shoulder. Okay, let me do this. Let me clear that off. Okay, so on the scale right here, this is important. See these values, this is 5 to 10. You're going 5 to 10 what? 5 to 10 knots. That's very light winds. In other words, and this is the time frame of 7 o'clock. Let me go back an hour, or back 3 hours. Wind speeds around 10 to 14 miles per hour, looks like, in this vicinity of the dry line. And there's not a whole lot of convergence. As we talked about, it's pretty laminar here. So with the weaker wind speeds in the puny convergence along this dry line. You need something a little bit better to get those supercells to go. So you better have no cap at all. In other words, no lid in the atmosphere, no inversion layer. If you have one, this is not going to be enough to bust through it. Now the models, because of all the moisture they think is going to be there, they erode that cap and they say, hey, there's no cap, so the lack of moisture conversion won't be a problem. They'll just go on the theta E axis, which is the warm and stable moisture axis, and that'll be enough. So it's going to come down to whether or not we really have the moisture. I'm sorry, that's the way it's going to be. I'm giving you all the explanation behind the thought process. I've given you all the details and what it is we're looking at. And in the end of the day, if those low 60 dew points don't get here and they're not deep enough, then there's not much of a show to be had as far as anything traumatic like that. So if all of a sudden somehow from off Texas shore we get the low 60s and it's deep moisture, then yeah, all bets are on for some good old-fashioned supercells producing probably a couple of tornadoes right here in central Oklahoma, and then points south and points east to here. So tomorrow morning at 9 o'clock, we'll have a better idea as to what value of moisture we're really going to have here. So sometimes these things aren't that clear. That's why I give you a rule, no talking about tornadoes at all prior to 48 hours out. And here we are 24 hours out, a little less than that, and we're still trying to talk about tornadoes, but we really can't because the models don't have a good grasp on the low level moisture. So that's one ingredient extremely important in this situation. Now, if you don't get it, you get dew point values in the low 50s or even mid 50s, you'll still get some storms and you'll still get some hail and some wind. That's not out of the question. You won't get very many widespread ones, and they probably won't last too long at that level of severity, but you'll get them. So that is it. I know it was pretty long-winded, but it's a Saturday night, and I got nothing better to do. So I'm out here helping you out, just giving you all the in-depth behind-the-scenes stuff that you normally don't get a chance to see. And when you do that, you tend to be a little long-winded. Some of these I try to keep much shorter. I always aim for like 7 minutes, and it never seems to work out, except on a rare occasion. If you're gonna here's one more thing. If you're gonna post to my wall, hey, what is this about this, that, and the other, and who says this and who said that? Honestly, I don't have time for any of that. I don't look at anybody else's stuff. I'm way too busy. I won't even know what you're talking about. Plus, I'm not going to sit there and bash on one guy and knock another guy for their forecast. Because you roll the dice enough, you're going to miss one. The idea is you get more of them right than you get wrong. And so that's what I kind of focus on. And that's about it. So that is it tonight, guys. I do want to appreciate you tuning in to Facebook Live here on the Severe Weather Update and my YouTube channel, which I also simulcast on my on YouTube when I do these live broadcasts, and also when I stream live severe weather coverage. So in the morning, I'll do another update. And if it looks like there's a threat for tornadoes, then more than likely I will be doing live streaming coverage tomorrow late afternoon and evening. If it does not look like there's going to be a tornado potential at all, I might just run the radar in the background. But as many of you have alluded to, if I'm on, it's a big deal. If I'm off, and it's typically not a big deal, unless I've said, I'm out of pocket and I can't be here, out of vacation or something, who knows. But that's a rarity. So that is it, my friends. All right, well, thanks for tuning in. And again, we'll talk with you tomorrow. Have a good night.